Hello, this is Nika. The topic of my presentation is the humerus. Today, I will tell you about its structure. But first, let's start with some general information about it. The humerus is an elongated bone in the arm extending from the shoulder to the elbow. It forms a connection between the scapula and the two bones of the forearm, the radius and ulna, and is divided into three parts. The upper part of the humerus includes a round head, a slim neck, and two brief processes. The body is cylindrical at the top and more prism-like at the bottom. The lower part is made up of two epicondyles, two processes, and three fossae. In addition to its actual anatomical neck, the narrowing beneath the humerus's greater and lesser tubercles is known as its surgical neck due to its propensity to break, making it a common area of interest for surgeons. The next thing we will cover is the structure of this bone using a 3D model as an example. I will be showing various elements and providing explanations for them. So let's get started. Head. This large, nearly hemispherical head is at the top of the bone. It connects to the glenoid cavity of the scapula, shoulder blade, to form the glenohumeral joint. Men generally have a larger humeral head than women. Anatomical neck. Just below the head, there's a slightly constricted area called the anatomical neck. It attaches to the shoulder joint's articular capsule and has many blood vessels passing through it. Fractures here are rare. Surgical neck. Further down, we find the surgical neck. It's a narrow region below the tubercles, small bony projections. Fractures often occur here. The surgical neck interacts with the axillary nerve and the posterior humeral circumflex artery. Greater tubercle. This large projection sits on the backside of the humerus. It's where muscles like the supraspinatus, infraspinatus, and teres minor attach. The crest of the greater tubercle forms part of the bicipital groove and provides a site for the pectoralis major muscle to insert. Lesser tubercle. This smaller bump is located anterolaterally to the head of the humerus. It provides attachment for the subscapularis muscle. Both the lesser and greater tubercles are in the upper part of the humerus, intertubercular sulcus. Between the tubercles, there's a deep groove called the bicipital groove. It houses the long tendon of the biceps brachii muscle and carries a branch of the anterior humeral circumflex artery. The groove runs obliquely downward and ends near the junction of the upper and middle thirds of the bone. Shaft. The humerus shaft has a triangular to cylindrical shape when cut. It's compressed from front to back. Radial groove. Located on the posterior surface of the shaft, this shallow, oblique groove accommodates the radial nerve and deep vessels. It's just below the deltoid tuberosity. Deltoid tuberosity. On the lateral surface of the shaft, you'll find a roughened area called the deltoid tuberosity. This is where the deltoid muscle attaches. Distal end. The lower part of the humerus is flattened from front to back and curves slightly forward. It ends in a broad, articular surface divided by a slight ridge. Medial and lateral supracondylar crests. These sharp borders continue from the medial and lateral epicondyles, respectively, on the distal humerus. Medial epicondyle. This bony prominence on the humerus is larger and more noticeable than the lateral epicondyle. It points slightly backward in the anatomical position. Coronoid fossa. Located above the front part of the trochlea, the humerus's pulley-like structure. This small depression receives the coronoid process of the ulna during forearm flexion. Capitulum. Forming the lateral part of the distal humerus, the capitulum articulates with the head of the radius. Radial fossa. Just above the front part of the capitulum, this slight depression accommodates the anterior border of the radius head during forearm flexion. Lateral epicondyle. Curving slightly forward. This small bump provides attachment for the radial collateral ligament of the elbow joint and certain forearm extensor tendons. Lateral supracondylar ridge. A rough margin on the lower part of the humerus's lateral border. It serves as an attachment site for forearm extensors. Olecranon fossa. Positioned above the back part of the trochlea, this deep triangular depression receives the summit of the olecranon, part of the ulna, during forearm extension. Ulnar nerve groove. The larger and more prominent medial epicondyle directs slightly backward. It attaches to the ulnar collateral ligament, the pronator teres muscle, and some forearm flexor tendons. The ulnar nerve runs in a groove on the back of this epicondyle. Next, I want to discuss the functions of this bone. Let's start with the abduction and extension of the shoulder. This movement is facilitated by two muscles, the deltoid and supraspinatus. These muscles originate from the clavicle and scapula, respectively, and insert on the humerus. Next, we have the internal rotation of the humerus. This action is contributed to by the pectoralis major, teres major, and latissimus dorsi, which insert at the intertubercular groove of the humerus. The subscapularis muscle also plays a role in this action. In contrast, the external rotation of the humerus is managed by the infraspinatus and teres minor. These muscles insert on a different part of the humerus, specifically, its greater tubercle. Now, let's talk about the flexion of the elbow, an action we all do countless times a day. This movement is facilitated by the biceps brachii, brachialis, and brachioradialis, which attaches distally. The extension of the elbow is another common movement, made possible by the triceps brachii and anconeus. These muscles attach to the posterior side of the humerus. Lastly, but certainly not least important, is the stabilization of the glenohumeral joint. The four muscles supraspinatus, infraspinatus, teres minor, and subscapularis form what we call the rotator cuff. This musculoligamentous girdle stabilizes this very mobile but inherently unstable joint. In conclusion, our bodies are a marvel of nature, with each bone and muscle playing a crucial role in our daily movements and activities. Thank you for your attention.